Hi there, this is Estelle Trengove, and this is the lesson for ELEN2017 on superposition. Before we get to superposition, it's important to note that we can only use superposition on linear circuits, but luckily all the circuits that we consider in this course are linear circuits. You will deal with nonlinear circuits in other courses, and remember then that superposition does not apply to those nonlinear circuits. So to find out what linearity means, we're going to look at that quickly first. And if something is linear, it implies that it is both scalable and additivity applies. So it has to have both of those attributes. Let's look quickly at what scalability means. Scalability means if you have some black box system. So let's represent the system like this. And for any input X into the system, you get an output Y. Then scalability means that if you put an input of 2X into the same system, then the output will be scaled by the same amount, so the output will be 2Y. Additivity means that if you have some black box system, so let's call that system 2, and for an input X1, you get an output Y1, and for the same system, for an input X2, you get an output Y2. Then additivity means that if you add the inputs together, so if you input X1 plus X2 into the system, then you will get an output Y1 plus Y2. And that's important because this principle implies that for a linear circuit, we can consider each of the sources one at a time, and then to get the overall effect of all the sources on the circuit, we can just add those results to each other. So what does this mean for electric circuits? It means that we want to turn off all the sources in the circuit so that they have no effect on the circuit, and consider the effect of only one source at a time. And so the question is, how do we turn off the other sources? Let's take a look at this little circuit over here, and we want to first consider the effect of the 4 milliamp source only. Remember that a short circuit has a 0 voltage drop across it. So what we effectively want to do is we want to turn a voltage source, we want that to become 0 volts, and so to turn off a voltage source so that it doesn't affect the circuit, we replace it with a short circuit. So we turn off a voltage source by replacing it with a short circuit. Okay, so if we do that with this circuit, then what we have is a circuit that effectively looks like that. We still have the 10 kilo ohm resistor. We've got our 4 milliamp source. We've got a 2 kilo ohm resistor here and an 8 kilo ohm. And we want to find out the voltage V out. But remember, this is just considering one source, so it isn't the whole of V out. Let's call it V out dashed. And over here, we have a short circuit. So you can see that over here, the voltage is effectively 0 volts. So therefore, we've turned the voltage source off. By replacing it with a short circuit. And sometimes we use the abbreviation SC for short circuit. So by turning this voltage source off, we've now ended up with a circuit like this. Let's give some of these currents some names. So we're going to call this current flowing here I1, and this current here flowing is I2. And you can see that we've got a 10 kilo ohm resistor there, and these two are in series with each other. We're interested in the voltage across the 8 kilo ohm, but these two together are also 10 kilo ohm. So we can see that the 4 milliamp current splits equally between the two branches. So we can see that I1 is equal to I2, and that is equal to 2 milliamps. So we know that the current flowing through this 8 ohm resistor is I2, which is equal to 2 milliamps. And now we can work out V out just by using Ohm's law. So we know that V out dashed is equal to 2 milliamps times 8 kilo ohms. And so therefore V out dashed is equal to 16 volts. Now we want to consider the effect of the 6 volt source only, and we want to turn off the 4 milliamp source. So that means we want to take a current source and we want to turn that current source to 0 amps. And so remember that an open circuit has 0 amps flowing through it. So if we want to turn off a current source, then we replace it by an open circuit. So we replace a current source with an open circuit. So let's do that with this circuit, and then what we have is we've got the 6-volt source, we've still got the 10 kilo ohm. Now over here we have an open circuit, we've still got the 2 kilo ohms and the 8 kilo ohms. And the voltage that we're going to calculate here now, we'll call that V out double dashed. And so you can see that over here, where this open circuit is, there's 0 amps flowing here. So therefore, the current source has been turned off. And we use the notation V out double dashed because this is the part to V out that is contributed by the 6-volt source. Now you can see that this 10 kilo ohm resistor and the 2 kilo ohm resistor are in series. So what we have here is a simple voltage divider where the voltage is dividing across this 12 kilo ohms and the 8 kilo ohms. So we can calculate V out dashed by using the voltage divider equation. V out double dashed, sorry. So V out double dashed is equal to 6 volts times 8 kilo ohms divided by the 12 kilo ohms plus 8 kilo ohms. And this gives us V out equal to 2.4 volts. And now remember that to find V out is equal to V out dashed plus V out double dashed. And remember we said that V out dashed was 16 volts. And we've just calculated V out double dashed, and that is 2.4 volts. So V out is equal to 18.4 volts. And so to summarize, for superposition, to switch off a voltage source, we replace it by a short circuit, because there's zero volts across a short circuit. So in other words, if we have a voltage source, we replace it by a short circuit. And to switch off a current source, we replace it by an open circuit, since zero amps flows through an open circuit. So if we have a current source, IS, in a circuit, then we replace that by an open circuit. And we know that there's 0 amps flowing there. And then lastly, remember that you have to add together the results of all of each bit. And then your superposition is complete. But the important thing to remember is that you switch off a voltage source by replacing it with a short circuit, and you switch off the current source by replacing it with an open circuit. That's all the end of this video.